What if you fell into a black hole? Picture yourself drifting weightlessly in the depths of space, surrounded by an endless void. Millions of stars twinkle in the distance. But in front of you lies a region of absolute darkness, no light, no color, just an invisible emptiness. You don't know what it is. Only that an unseen force is pulling you toward it. You are approaching a black hole. From the moment you get caught in its pull, everything around you begins to distort. The light from distant stars behind you bends in strange ways, forming a glowing halo around the dark void. This is not just an empty space, this is a black hole. One of the greatest mysteries of the universe. A black hole is not an open gateway to nothingness but rather an ultra-dense mass with a gravitational force so powerful that even light cannot escape. It is not a literal hole but rather a region where space-time is stretched to its absolute limit. According to Einstein's theory, black holes form when a massive star runs out of fuel and collapses under its own gravity. But instead of becoming a planet or a lifeless remnant, gravity crushes all of its matter into an infinitely small point, creating a space-time region where the usual laws of physics no longer apply. Despite being terrifying cosmic entities, black holes play a crucial role in shaping the universe. At the center of most galaxies, including our Milky Way, there exists a supermassive black hole. It acts like a giant engine, influencing the orbits of billions of stars and holding the galaxy together. Scientists also believe that black holes might be the key to understanding the true nature of space and time. Some theories suggest they could be portals to other universes or even gateways through time. If that were true, would you dare to step into the darkness to find out? Imagine standing on a distant planet, gazing at a star-filled sky. A giant star, 10 times the size of our sun, shines brilliantly in the distance. But after millions of years of burning brightly, the star begins to change. It dims, then suddenly swells dramatically. Its light flashes one last time before collapsing into itself. As the surrounding gas and dust disperse, all that remains is a region of absolute darkness. A black hole is born. A black hole is unlike anything else in the universe. It is neither a planet nor a dying star. Instead, it is a region where gravity bends space to its extreme, where nothing, not even light, can escape. This makes a black hole essentially a cosmic ghost, existing yet completely invisible to the naked eye. But how can something that swallows light be born from a blazing star? The answer lies in the death of a massive star. Massive stars sustain themselves by burning nuclear fuel, which creates an outward pressure to counteract the inward pull of gravity. However, when the fuel runs out, nothing can hold the star up anymore. It collapses in a spectacular explosion known as a supernova, releasing an immense amount of energy. But the remaining core after the explosion doesn't disappear. It continues to shrink under its own gravity. If this core has a mass at least 3 times that of the Sun, nothing can stop it from collapsing into an infinitely small point, creating a black hole. Not all black holes are the same. They come in different sizes, from city-sized objects to monstrous entities as large as our entire solar system. Scientists classify them into 2 main types, formed from the collapse of a massive star, typically a few dozen kilometers across but with a mass several times that of the Sun. Scattered throughout galaxies, often hidden in darkness or feeding on nearby stars. Millions to billions of times the Sun's mass. Found at the centers of galaxies, acting as gravitational anchors for billions of stars. The Milky Way's supermassive black hole, Sagittarius A, has a mass 4 million times that of the Sun. The origin of supermassive black holes remains a mystery. Some theories suggest they formed from the merging of smaller black holes, while others propose they have existed since the birth of the universe. Now, let's return to you, the brave explorer drifting through space. In front of you looms a black hole. It emits no light, yet a swirling disk of searing hot gas surrounds it, releasing deadly X-rays. You know that if you take one more step forward, there will be no way back. What would happen if you actually fell into a black hole? Would you be instantly crushed? Or would you drift into an unknown space no one has ever seen? You are floating in space. moving closer to the enormous black hole in front of you. Around you, the light from the stars starts to distort, twisting into strange shapes. It feels as if the universe itself is spiraling around an invisible point, where light is being swallowed. Space no longer appears as a familiar flat plane. It is bending in ways you've never seen before. You have just entered the gravitational field of the black hole. Every object with mass generates a gravitational field, from a small rock to Earth, the Sun, and even larger celestial bodies. However, a black hole has such an incredibly strong gravitational field that it bends both space and time around it. Imagine the universe as a stretched-out sheet of fabric. Placing a small ball on the fabric creates a shallow dip. This represents how Earth or the Sun curves the space around them. But if you replace the ball with a black hole, the dip would be so deep that it forms a bottomless pit, where anything that falls in can never escape. This is the true nature of a black hole. A region of space-time so distorted that even light, the fastest thing in the universe, cannot escape. Imagine you are standing on the Sun. If the Sun had a solid surface, its gravity would be 28 times stronger than Earth's. This means that if you weigh 70 kilograms on Earth, you would feel like you weigh nearly 2 tons on the Sun. But that is nothing compared to a black hole. Now, imagine standing near the edge of a stellar black hole, the smallest type of black hole. The gravity there is so powerful that if you tried to take a step, the pull would be so immense that it could tear apart every single cell in your body. If you were near a supermassive black hole, the gravity at the outer edge might be less extreme. But once you're drawn in, there is no escape. As you get closer to the black hole, the light from the stars behind you starts changing colors. It becomes redder and weaker, as if being stretched out in space. This is not an illusion, it is a real physical phenomenon known as gravitational redshift. Light is a type of wave, and as it struggles to escape the black hole's strong gravitational field, its wavelength gets stretched, making it appear redder. The closer you get to the black hole, the redder the light becomes, until it stretches so much that it completely disappears from view. This is why black holes appear pitch black. If someone were watching you from a distance as you fell into a black hole, they would see you slowing down and gradually fading. As you approach the event horizon, the light reflecting from your body would be stretched infinitely, making it seem as if you were frozen in place forever. But for you, time would continue as usual. You would keep falling into the mysterious abyss. A black hole doesn't just warp space, it also alters the flow of time. The closer you get, the more time slows down relative to an outside observer. If you could somehow survive long enough inside a black hole and look outward, you might witness millions of years passing by in the universe in just a matter of seconds. You are drifting in space, being pulled into the immense gravitational force of the black hole. The stars around you begin to distort, and the light seems to be sucked into an invisible point ahead. You know you are approaching a mysterious boundary from which no traveler has ever returned, the event horizon. A black hole has a terrifying characteristic. Once you cross the event horizon, nothing can escape, not even light. The event horizon is not a physical surface but an invisible boundary where space and time are so warped that every possible path leads only deeper inside. Imagine you are paddling a boat near the edge of a massive waterfall. Far from the drop, the water flows calmly, and you can easily turn around. But as you get closer, the current becomes stronger, and no matter how hard you row, you can't escape. You're pulled over the edge. The event horizon works the same way. Once you cross it, any effort to escape the black hole becomes meaningless. If a distant observer were watching you, they would witness a bizarre phenomenon. As you approach the event horizon, they would see you moving slower and slower, as if caught in slow motion. According to Einstein's theory of general relativity, the intense gravity of a black hole slows down time. The closer you get to the event horizon, the slower time passes for you compared to the outside world. To an observer far away, you would appear to freeze in place at the event horizon, as if stuck in time forever. But in reality, you don't actually stop. To you, time continues to flow normally, and you keep falling into the black hole without noticing anything strange. The moment you pass the event horizon, everything turns dark. You look outward into space, but the light from the stars begins to fade, as if being blocked by an invisible curtain. At this point, every possible escape route has disappeared. No force is strong enough to pull you out because space inside the black hole no longer behaves like the universe outside. Even if you had a spaceship that could travel faster than light, you wouldn't be able to escape, because every possible direction now leads to a single point, the singularity, where all matter is crushed. You can't send any signals back to your team. Every message, every beam of light, every cry for help is trapped within the black hole's boundary. You have completely vanished from the universe you once knew. Is this truly the end? Or is there a way to defy the laws of physics and emerge somewhere else? Some scientists, including Stephen Hawking, have proposed that black holes might be gateways to parallel universes. If so, falling into a black hole might not mean destruction but rather reappearance in another reality. You are floating in space, drifting toward a massive black hole. Even though you are fully aware of the danger ahead, you can't resist your curiosity. You want to know what really happens when someone falls into a black hole. Is it an instant death? Or is there a way to survive? If you are unlucky enough to fall into a stellar black hole, a type of black hole with a mass several to dozens of times that of the Sun, you won't have the chance to observe any wonders inside. As you approach, the gravitational force difference between the part of your body closer to the black hole and the part farther away becomes extreme. If you fall in feet first, the gravitational pull on your feet will be significantly stronger than on your head, stretching your body apart. In a fleeting moment, you feel yourself being pulled and elongated, and before your brain can even process what's happening, you are torn apart at the atomic level. Physicists call this phenomenon spaghettification, a process in which objects are stretched infinitely under an extreme gravitational pull. What remains of you will continue to be crushed and absorbed into the chaotic mass of matter surrounding the black hole. However, if you fall into a supermassive black hole, one with a mass millions or even billions of times that of the Sun, your fate could be different. In these black holes, the event horizon is much larger. This means that the gravitational difference between different parts of your body is smaller, allowing you to cross the event horizon without being torn apart immediately. You continue to fall inward, drifting through an endless darkness with no way back. At this point, the usual laws of physics seem to break down. Everything around you appears distorted, and time seems to slow. You see light bending into strange spirals. If you remain conscious long enough, you might even wonder, is this the end? Or is this a gateway to somewhere else? The deeper you fall, the stranger space becomes. You begin to feel your body stretching, slowly but inevitably, due to spaghettification. You realize that even though a supermassive black hole gives you more time to witness your own demise, the singularity still awaits ahead. And once you reach the singularity, all known laws of physics collapse. But is there another way? Some scientists believe black holes might be connected to white holes, a theoretical counterpart that does the opposite, expelling everything instead of pulling it in. If that theory is true, then instead of being destroyed, you could emerge somewhere else in the universe, or even in an entirely different universe. You have chosen to plunge into a black hole. But if a companion were watching you from a distance, what would they see? Would they witness you being stretched, instantly crushed, or simply disappearing in a flash? In reality, what they observe would be entirely different from what you experience. From an external observer's perspective, as you approach the event horizon, your movement seems to slow down. At first, you appear to fall quickly. But the closer you get to the black hole's boundary, the slower you move, as if something is holding you back. The truth is that time near a black hole moves significantly slower than it does outside. According to Einstein's theory of relativity, if your companion had a watch, they would see your time almost coming to a halt. To them, you would never actually fall into the black hole but would appear to freeze right at the event horizon. Not only time, but the light emitted from you is also affected. As you move closer to the black hole, the light reflecting off your body must fight against the immense gravitational pull to escape. This causes the wavelength of light to stretch, a phenomenon known as gravitational redshift. To an outside observer, the light from you would gradually shift from white to red, then to deep crimson, and finally black, before disappearing completely. You would no longer reflect light, and the outside world would be unable to see you. In reality, you have already fallen into the black hole. But to an outsider, you appear to be hovering at the edge of the event horizon. They can never see you cross the boundary because all information from you is infinitely stretched. Eventually, you fade, dimming slowly, and then vanish as if you never existed. A silent death, with no sound, no trace. You have passed the event horizon. There is no turning back. Nothing can escape, not even light. But what awaits you inside? Darkness engulfs everything. No light, no sign of the universe outside. You are being pulled toward the black hole's core, a place where all known laws of physics seem to collapse. At the heart of the black hole lies a mysterious entity called the singularity. This is a point where all matter is compressed into a region of infinite density and infinite gravity. No scientist can say for certain what happens if you reach this point because all familiar physical laws break down. Here, space and time no longer function as we know them. There is no past, no future, only an endless flow toward the singularity. You have no control over your movement. Every possible path leads to the center. And nothing can stop it. Some scientific theories propose strange possibilities. White holes. Some physicists believe black holes may be connected to white holes, the opposite of black holes. While black holes pull everything in, white holes can only expel matter. However, white holes remain purely theoretical and have never been observed in the universe. Wormholes. Another hypothesis suggests that black holes could serve as gateways to another universe or a different part of our own. If true, you might not be torn apart upon reaching the singularity, but instead, travel through a space-time tunnel and emerge somewhere else. However, if this theory is incorrect, you will simply be crushed into an infinite point, becoming a part of the black hole forever. You keep falling, crossing the boundary of perception and science. No more light, no more escape. But what if this is not the end? Stephen Hawking and the multiverse hypothesis. The great physicist Stephen Hawking once proposed a bold idea. Black holes could be gateways to another universe. According to quantum theory, information can never be completely lost. This means that everything that falls into a black hole may not be destroyed, but instead could reappear in a different reality, a parallel universe to our own. In one reality, you are torn apart and crushed into atoms. But in another reality, you are still alive, just no longer in the same universe. This raises a profound question. Are black holes truly the end of everything? Or are they merely transit stations leading to distant realms? Another theory suggests that every black hole could be connected to a white hole. While a black hole pulls everything in, a white hole does the opposite. It ejects all matter outward and does not allow anything to enter. If a pathway exists between a black hole and a white hole, it could mean that you are pulled into a black hole, only to be released somewhere else in the universe, or even in an entirely different universe. You feel weightless, as time flows strangely around you. The familiar laws of physics no longer apply. Suddenly, a beam of light appears before you, not the light of stars, but something entirely different. Have you reached the other side of the black hole? A place no one has ever known? Are you still yourself? Or have you become a different version of yourself in an alternate reality? You no longer know how long you've been falling. It could be just a few seconds, or perhaps millions of years. But outside the black hole, time still moves forward. And according to Stephen Hawking's theory, even black holes do not last forever. Hawking radiation, the slow death of a black hole. In 1974, Stephen Hawking made a groundbreaking prediction: black holes can evaporate, despite their immense gravitational pull. Quantum mechanics suggests that space around a black hole is not truly empty. Virtual particle-antiparticle pairs constantly appear and disappear. When one of these pairs forms right at the event horizon, one particle may be pulled into the black hole while the other escapes. From the perspective of an outside observer, The black hole is losing mass as it continuously emits this radiation. This process is extremely slow for supermassive black holes, but much faster for smaller ones. Eventually, the black hole will shrink, become increasingly hot, and end in a violent explosion, releasing all of its remaining energy. What happens to you when the black hole disappears? If you have already been pulled into the singularity, where space and time are crushed beyond recognition, then you may have vanished completely from all known physical laws. But if information truly cannot be destroyed, as some scientists believe, then the particles that made up you may be released back into the universe when the black hole evaporates. But will those particles still be you? Or will they just be nameless remnants, stripped of any memory or consciousness? Some theories suggest that information may still exist in an encoded form, imprinted within Hawking radiation, though no longer in any recognizable way. Perhaps you have dissolved into pure energy. Or maybe some part of you has traveled to an entirely different reality. Outside the black hole, scientists might observe the final burst of radiation as it explodes and disappears. But for you, the one who fell inside, there is nothing left to witness. It may be the true end, or the beginning of something no one has ever known. Standing at the edge of the event horizon, you stare into the infinite darkness ahead. A black hole, a cosmic entity that swallows light itself, remains as mysterious as a gateway to something unknown. Science has advanced far, yet no one has a definitive answer to what truly happens inside. From Einstein's classical theories to the most advanced research in quantum mechanics, black holes remain one of the most enigmatic and terrifying phenomena in the universe. They are not just regions of immense gravity, they are places where the very laws of physics might collapse. We know that black holes form from the death of massive stars, that they may evaporate over time due to Hawking radiation, and that inside them might exist a singularity where matter is crushed to infinity. But all of this is just theory. No one has ever returned to tell what truly lies within a black hole. Imagine that one day, humans develop the technology to travel to a black hole. A brave astronaut takes the ultimate leap into that darkness. But will he be stretched into thin strands of matter by spaghettification? Or will he be pulled through a wormhole leading to another universe? The answer remains beyond humanity's reach. But one thing is certain. A black hole is not just a cosmic monster. It could be the key to unlocking the greatest mysteries of space, time, and reality itself. Black holes, both terrifying and captivating, remain an unsolved mystery in the universe. Are they a place of absolute destruction? Or could they be a gateway to another reality? These questions remain unanswered, waiting for humanity to explore in the future. If you found this content fascinating and thought-provoking, leave a comment below and share your thoughts. Would you dare to enter a black hole if given the opportunity? Or do you think black holes hold the key to the greatest secrets of the universe? Let's discuss.